So this is the No Calculator Day 1 FRQ. Read the directions. They give us 2 points. They give us point Q and point S. So, and let me remind you guys that when you take the test, you'll have your FRQ on a full sheet of paper like I do. It's not going to be a half sheet. So just do the best you can squeezing the answers in. And on the test, you'll be able to write on your graph, okay? So it's not like on a separate sheet of paper. You can write on your FRQ. All right, so they give me 2 points. It's up to you if you want to label them or not. I like to have my graph as labeled as possible. It helps me, my brain. But these 2 points I'm putting on in blue are given to me in the directions. Your FRQ on the test day will look just like this. Guys, listen, it's going to be the same questions. The questions don't change. The graph changes. So it's exactly the same. So if you can do this one, you should be able to do the other one. So let's do this. So I labeled point Q and point S that were given. And the first thing it asks for is the domain and range. Okay? The domain is your X values, range is your Y values. This is a polynomial that doesn't have a whole, it doesn't have an asymptote. So the domain is all real numbers. As we go up, we're going left and right forever. So we're going to write that in interval notation, negative infinity to infinity. We always use parentheses on infinity symbols. The range is your Y values. That's not all real numbers. Right here, guys, we had a question similar to this on our first test. So the fact that I'm doing it again must mean it's pretty important stuff. The range is your Y values, okay? And right here, a lot of my students got a point off because they messed up the range. The range is from negative 5.7 up forever, right? That is my lowest Y value that I would use, negative 5.7, and then it goes up, okay? Where students messed up is right here. Do I put a, well, we know that the parentheses will go on the infinity symbol always, but is this going to be a bracket or a, yes, it is a bracket. It is part of the graph. That's a filled in hole. That is a point on the graph. It was given to us. It is part of the graph. A lot of you put parentheses on the last test and got a point off, okay? So remember that it has to be, it's part of the graph, okay? It doesn't have to touch negative 5.7 like the y-axis or whatever. It just has to be a filled in hole. Okay, turning points. Turning points are where the graph changes from decreasing to increasing. So that would be a turning point. Or increasing to decreasing. So there are 3 turning points. They are points, meaning ordered pairs. So we're going to name them. This point right here would be negative 3, 0. This point here was given to us, negative 1, 1. And this point also was given to us. Okay? Now listen, that's just the first part of it. Find the turning points. It says to give a reason for your answers. So I'm going to give a reason of what makes this a turning point. Well, negative 3 is a turning point because f of x changes from decreasing to increasing. And you can totally abbreviate. Why is negative 1, 1 a turning point? Because f of x changes from increasing to decreasing. Totally fine to do some little shorthand there. You don't have to write the whole thing out every time. Right? It goes from increasing to decreasing right there. And at 2.6, negative 5.7, we go from decreasing to increasing. Turning points make sense? Everybody understand that? Points of inflection, POIs, that is the number of turning points minus 1. So we have 3 turning points minus 1. We're going to have 2. You don't have to write that on the test. I'm just giving you some information there. There should be 2 points of inflection since there are 3 turning points. We always subtract 1. Remember what a POI is. It's where concavity changes. It's where we go from concave up to concave down or vice versa. When you take calculus, you'll actually get an exact POI. But in pre-calculus, we use an estimation technique called the midpoint formula, okay? And this was on your last test. A lot of you skipped it. We're going to go over that. So the midpoint formula for the midpoint between two turning points is your POI. So in between this point and this point, you can see point P. That is a POI. I'm going to just call it POI number 1, just because. And then in between these two turning points, we have another POI. We'll call it POI number 2. Now, you do not have to write that on your graph for credit. I'm just being very thorough here, okay? You don't have to write anything on your graph if you don't want to. What I'm grading is this. All right, so what we have to do is find the midpoint between these two and the midpoint between these two. Guys, and some of you are like, I don't have it memorized. I don't have the formula memorized. You don't need to memorize if you just think about what it is. Middle of two numbers. So if you want to find the middle between two numbers, you add them together and divide by 2, right? You just split the difference between them or find the average, okay? I'll write the midpoint formula for you, but I don't want you to have to like memorize it. Think about what it is. It's going to be an ordered pair. So we add our x's together, divide by 2, add our y's together, divide by 2. That's the midpoint between 2 points. Okay, so I'm going to identify my 2 points, and this is optional as well. You don't have to write what the 2 points are for time's sake. You know what I'm saying? Negative 1, 1. All right, so I'm going to find the midpoint between these 2 points, which are these. So that would be negative 3 plus negative 1 divided by 2, and 0 plus 1 divided by 2, right? Add my x's, divide by 2, add my y's, divide by 2. And I will get negative 4 over 2. You have to do this without a calculator. And 1/2 or 0.5. Okay? So that is POI 1. POI number 2 would be between these two. So it's negative 1, 1, and 2.6, negative 5.7. So let me set it up and then I'll explain something. Add my x's, divide by 2, add my y's, divide by 2. And I don't know how this problem got on this part of the test because it's no calculator. I do not expect you to be able to, I mean, it's not impossible, by the way, to divide these two, but it's not something you have to be able to do for this class. So if you get a question like this on the test, feel free to go further if you want, but if you want to leave it just as 1.6 over 2, I'm totally fine with it. It's actually 0.8 if you want to be exact, but I'm fine with you not going any further. Same thing here. 1 plus negative 5.7 would be negative 4.7 divided by 2. You can leave it like that. I can't really fit it. Okay. So I haven't had a chance to look at the test. You might get weird decimals like that. Totally fine to leave it like that. Okay, and just know that if you were allowed to pick up your calculator, you would just divide it and get the exact decimal answer, but we don't care. Okay, so there's my POI number 2. Multiplicity for each 0. So zeros, roots, x-intercepts, x values, that's where the the graph crosses the x-axis. We have 1, 2, 3. Those are my zeros. Let's identify them. We have a 0 or root at negative 3. We have another one at 0. We have another one at 4. Right? Those are my x-intercepts, roots, zeros, whatever. So that's part of the question. The other part is describe the behavior of the graph at each root using the multiplicity. So you have to state the multiplicity. How do we know that without having like something that we factored, set the factors equal to 0? It all comes down to this. If you bounce off the x-axis, another way of saying that is to touch and turn, like at -3. That means you're going to have even multiplicity. Now, if you want to assign it a number, you could say it's a multiplicity of 2, a multiplicity of 24, a multiplicity of 1,058,000. As long as it's an even number, you're good, okay? But technically, we don't really know what the multiplicity is. If you looked at my key, I wrote like multiplicity of 2, because that's like the most common even number we see. But really, it doesn't matter. As long as you say even or pick any even number, okay? These two, 0 and 4, oh, sorry, let me back up. Why is it even multiplicity? How do we know that? Because it bounces. Or you could say touch and turn, okay? At 0, look at 0, look at 4, we cross. We go right through it, right? You get to it, you keep going, you just keep on driving through town. You don't stop. That would be odd. If you want to call it multiplicity of 1, multiplicity of 3, multiplicity of 7, any odd number you could, but just saying odd is good enough. How do we know that? Because it crosses. Last question. State the interval or intervals on which f of x is decreasing and concave up. Okay, let's start with decreasing. We are decreasing here and here, right? That's where the graph is going down. But where is it also concave up? This is right here, right? This is good. This section of the graph is decreasing, and you can see it's like part of a happy parabola. That would be from -infinity to what number? -3, right, Remy? And we're always going to use parentheses here, okay? Is it happening anywhere else? Yeah. This is decreasing, but it's concave down. At this POI, we switch and we become concave up. Remember, that's what a POI is. It tells you where your concavity changes. So it changes at -1 to what number? No, wait, not -1. Sorry, not -1. This x value. What's this x value? It's this. Yeah. 1.6 over 2. Yeah, right. So it from here to here is the interval we want. So this is 1.6 over 2. This is concave up. You see it, Evan?
Oh, I thought we didn't have to.
If you put a U, it's fine. If you put a comma, it's fine. Either way. I can work until the bell rings. What, Haley? Since that's on the calculator portion, I'm going to save it for Monday, okay? Because we still have Monday. Number 7, Remy, you have to first factor. And then you get your zeros. And the answer is 3 distinct, which means unique, different. There's no doubles. It's all multiplicity of 1. That's why it's 3. They're all real. We didn't get any negatives under a radical. That's what that means. These are all real numbers. These have, I don't even know. But there's 3 distinct zeros. And 4 is a little bit long. I'm not going to be able to fit that one in. You can try. Yep.